Hey guys, so welcome to the second lecture for trigonometry. Okay, so this question says, a whale watcher is standing on top of a cliff that is 2,400 meters above sea level. He notices a whale 3,700 meters away from the cliff. What is the angle of elevation from the whale to the watcher? So again, guys, it's really critical that you draw out this particular scenario. So let's say that's the cliff there. Then a whale watcher is standing on top of the cliff. So from the cliff, he has a line of sight all the way out to the whale. Let's say the whale is here. Okay. And the cliff is 2,400 meters high. And the whale is 3,700 meters away. Okay. Now it says, what is the angle of elevation from the whale to the watcher? Okay. And that's the angle that we're looking for right there. Because as we know, angle of elevation is simply when you're looking up at something. So that the angle that it makes, the angle that your line of vision makes with the horizontal is the angle of elevation. Okay, so let's call that angle theta. So we have, again, looking at the opposite end, and we have the adjacent here. So out of the so, ka, and toa concepts, we know that once again we have to use toa. So tan of theta is equal to opposite, which is 2,400 meters, over adjacent, which is 3,700 meters. As we know, the zeros will simply get cancelled out. So tan theta is equal to approximately 0.65. Taking the tan over to the other side, we have theta is equal to inverse tan of 0.65, which gives me approximately 33.02 degrees. So again, guys, to answer this question, please do answer it in a worded form. To answer in a worded form, it would simply be the angle of elevation from the whale to the watcher is 33.02 degrees. It's a perfect way to end the question. Okay, let's moving on to the next question. Okay, so this question says, Stanley is trying to figure out the angle of depression of the sun's rays by measuring his shadow. If he is 1.9 meters tall and casts a shadow of 0.9 meters, what is the angle of depression? So drawing this out, we have Stanley at 1.9 meters, quite a large man. Then he casts a shadow of 0.9 meters. And we are then looking at the angle of depression. And as we know, the angle of depression is the angle between the horizontal and the line of vision. So imagine that's the top of that's Stanley's eyes right there, and imagine this line here is his line of vision down to the end of his shadow. Okay, and that angle right there is actually the angle of depression, which happens to be the exact same angle as this particular angle here. So if you were to find the angle of elevation from the end of the shadow to Stanley's head or Stanley's eyes, it's actually the exact same angle as the angle of depression from Stanley to the end of the shadow. Okay, so once again, using our SOHCAHTOA, toa, we know that toa is what we need to use. So we have tan of theta, which is the angle, and then that is equal to opposite side, which is 1.9, divided by the adjacent side, which is 0.9. Therefore, tan theta is equal to 1.9 divided by 0.9, which gives us 2.11. Then taking the tan over to the other side, we get an inverse tan. So we have theta equals inverse tan of 2.11, which gives me 64.6 degrees. Therefore, the angle of depression, let's call it D, is 64.6 degrees. Fantastic. Let's move to the last question. Okay, so this question says, there's a spotlight that is being shown on the ground. Now, if the spotlight hits the ground 500 meters away horizontally and makes an angle of depression of 50 degrees with the ground, how high off the ground is the spotlight? Okay, so again, let's draw this out. Let's say that's the spotlight there. It is being shown on the ground. if it hits the ground, let's say that's the ground there. Let's say that's the ground there, and it hits the ground 500 meters away. So that's 500 meters right there, and makes an angle of depression of 50 degrees. So that right there is 50 degrees. So as we discussed, that will also mean that this is also 50 degrees. The question asks, how high off the ground is the spotlight? So we're looking for this particular side there, or this particular side there. So to make it a little bit more accurate, let's ignore that part there. So if I was to just draw this out a little bit more neatly, I would have a triangle with a 500-meter base, an angle of 50 degrees, and then we have to figure out the height. So once again, we can tell that it is opposite and adjacent. So we are looking at TOA again. So we have tan of 50 degrees, which is equal to x over 500. So x is equal to tan of 50 times 500, which gives me a value of 595.9 meters. So how high off the ground is the spotlight? Therefore, the spotlight is 595.9 meters off the ground. Beautiful. So that, guys, brings us to the second lecture for trigonometry. I really hope this has been helpful, guys. This, really explains the concepts of angle of elevation, angle of depression, how to use Pythagoras' theorem, etc. So, guys, make sure to have a go at the worksheets, and I will see you in the next lecture. Thank you.